So, you've heard of 3D printing, this exciting new technology that we can put right in the hands of our students and educators. But why would we even use a 3D printer for education? The power of the 3D printer is to encourage problem solving and critical thinking in our students. Using the 3D printer in your class is most effective when paired with instruction on the engineering design process, scientific method, gaze model, or another problem-solving tool. While it is interesting to create things, the most powerful learning comes when a design does not work, and the student asks the question, why? Through this experimental learning, students figure out effective design practices, the power of research before design, and the importance of testing a design. Most of all, students learn persistence. In subjects where problem solving is not as integral a part of the curriculum, the 3D printer can be used to print real, tactile objects to enhance learning. Imagine being able to model and print artifacts from an archaeological dig highlighting ancient civilizations, or using manipulative learning to teach grammar and sentence structure. Imagine printing the skeleton or fossil of an extinct species, or using connectable printed chromosomes to teach genetic inheritance, mitosis, and meiosis. Often, it is as easy as finding a file someone else has designed. Now that you are convinced of its utility, let's talk about the basic concepts of how a 3D printer works. A 3D printer consists of two basic parts, the printer head and the print plate. The printer head is where the material is inserted. 3D printers are most commonly use plastic. Ours takes only PLA, or polylactic acid. The printer head works like a hot glue gun, melting the plastic and depositing on the print plate. The printer head can move right, left, front, and back. The print plate moves up and down to meet the printer head. Once the model is prepared for printing, the printer head deposits the plastic, layer by layer, on the print plate. Once a layer is done, the plate moves down, ready for the next layer. Since pieces are printed from bottom up, it is important to consider a design that is flat on the bottom, or at least has enough material on the bottom to support material that would be placed on top. If that is not possible with your design, you can include supports, but we'll get to that later. The basic workflow from idea to print is just 3 steps. Once you have an idea, you will use a 3D modeling software to bring it to life. In our case, we will use Tinkercad. From Tinkercad, we will export an STL file and bring it to our slicing software, Dremel Print Cloud. Lastly, we will export a G3 Drem file and use the 3D printer to make it come to life. Don't worry, all the software is web-based, so all you need to get started is access to the internet. Good luck and happy making!